In this lesson, we're going to go over bond valuation and interest rates part 1, and specifically in this lesson we're going to go over bond valuation and interest rates part 1, and specifically we're going to be talking about bonds and bond valuation. For this lesson you'll need these notes, and you'll also need either Excel or a financial calculator that can work through time value of money problems. I'll be demonstrating the calculation of the problems using Excel. So a bond is a long-term contract, a debt under which the borrower or the issuer agrees to make payments of interest and principal on specific dates to the holder of the bond, or the investors, or the bondholders is one way we'll refer to them. One thing that is important to understand here is that the issuer is the person or the firm that is taking out the debt. So when Walmart has bonds, they're the issuer. When they issue bonds, they're the issuer of the bonds. Bond features: bonds often, but not always, pay a coupon or a coupon payment. So this is the payment made usually on a semi-annual or annual frequency. It's referred to as a coupon payment, and I want to show you here where this name comes from. Most of the bonds we'll be talking about are coupon bonds. So out here we have an example of a coupon bond. This was issued in the late 1800s by the Labrador Company, a company out of Canada. The face value of this bond, and we're going to go through these terms here in a minute, but the face value is $1,000 and the coupon is $30. So once a year, in January of each year, if you owned this bond, if you were the investor, you would tear off one of these coupons and you would send it in to the company, and they would send you a check for $30 back. So that's why we call it a coupon bond, even though today you don't actually get physical copies in most cases of the bond. They're actually traded electronically, and so you don't have the bond, but we'll talk about that more later in another lecture. The coupon rate is the rate at which the bond payment is set. The coupon payment is based on the face value of the bond and the coupon rate. For example, if the coupon rate is 3% and the face value is $1,000, then an annual coupon payment would be 3% multiplied by 1,000, or $30 per year. And that's the example that I was just showing you with that coupon bond from the Labrador Company. If the payment were a semi-annual payment, the semi-annual payment would be 1/2 of the annual payment. Or the 3% multiplied by 1,000, and then we would take that and we divide it by 2 for 2 payments per year. So you'd have 2 $15 payments per year rather than 1 $30 payment. The face or the par value, and I just showed you that on the bond. It has a face value, that's what's written on the paper, $1,000. This is the amount that the investor is owed at maturity. So if we have a bond that matures in 10 years and if it has a 3% annual coupon payment, we would get $30 for 10 years, and then at the end of that 10 years we'd also receive the $1,000. The time to maturity is the number of years until the face or par value is due. The yield to maturity, and this is an important number, this is the rate of return on the bond. And it usually has dashes in here, so I'll go ahead and add those too. You'll also see this as the YTM. The important thing to remember about this is if you buy that bond, then that is the annual return you will receive on the bond if you hold it until maturity. If you sell it before the maturity date, you might not actually get that return. And that's very important here if the bond is held until the maturity date. As you'll see later on, if you sell it early, or if it's called early, then you may not receive that annual return. You'll also sometimes hear me refer to this as the cost of debt for the company, because it's what the return they're having to provide to their debt holders, to their bond holders. So a bond valuation problem consists of two time value of money problems. It's the present value of a lump sum. So this is the present value of the principal or the face value to be repaid at maturity. And the present value of an annuity. So it's a set of equal payments for a set time period. So we will assume in this class, unless I tell you otherwise, all bonds have a par value or a face value of $1,000, and that's also the principal value. The principal value or the face value of the par value is not the price you pay for the bond unless the yield to maturity is equal to the coupon rate, which we haven't gone through yet. But in most cases, that principal value is not the amount you're paying for the bond, it's what's due to you at maturity if you're the bondholder. So if a bond pays an annual coupon payment based on an 8% coupon rate, the yield to maturity of the bond is 9%, so the rate of return you'll receive as an investor is 9%, and the time to maturity is 7 years. What is the value of the bond today? So let's go ahead and work through this in Excel. So I'm going to go ahead and open up Excel. And so we're valuing a bond. We're finding the price of the bond today. And so we need to, in this case, use the PV or the present value function. So I'll just pull that up to see what inputs we need. We need the rate. So that rate is going to be your yield to maturity. The number of periods is going to depend on whether it is an annual bond or a semi-annual bond. So that means how often the coupon is paid. The amount of the payment, which we've discussed already. The future value, which is that par value at maturity. And then the type, an annuity due or a regular annuity. Now typically it's going to be an annuity due, or excuse me, a regular annuity, because the prices, you won't get paid the interest until the time has elapsed, until that first payment is due or the next payment is due. So that's what we need to know. So the rate is the yield to maturity. The payment is the coupon payment or the coupon rate multiplied by the face value. And that is for an annual payment, or the coupon rate multiplied by the face value and dividing that by 2 for a semi-annual payment. The number of periods in PER is going to be, for an annual payment, is the number of years until maturity and that, again, that's for an annual payment, and it is the number of years until maturity multiplied by 2, because we have 2 payments per year for a semi-annual payment. The future value is the par or face value of the bond. It means the same thing. And then we're looking for the present value. The type is usually 0 unless I tell you otherwise, but you should always assume that it's 0. Okay. So that gives us our input. So let's go back to that problem there, and we will go ahead and figure that answer out. So in this case, a bond pays an annual coupon payment based on an 8% coupon rate. The yield to maturity of the bond is 9%. The time to maturity is 7 years. So we can go ahead and put in here equals present value. My rate is the 9%, 0.09. My number of periods is 7 years. And my payment is going to be $80, so that's 0.08 times 1,000. And you can actually put it in the function here if you want, but I know what it is. 8% times 1,000, so I can put in $80. My future value is 1,000. And my type is going to be 0. And again, if you want, you can just leave off the 0 and everything and just, you know, put the parentheses after 1,000 to get the answer as well. So it's a negative number here because this would be an investment. You're going to take this money out of your pocket, and buy the bond. So it's $949.67 is the answer here. So the value of that bond today is $949.67. Okay. So now we're going to talk about premium versus discount bonds. So we have bond A and bond B. Bond A makes annual coupon payments based on an 8% coupon rate, has a yield to maturity of 9%, and a time to maturity of 7 years. What is the bond value of the bond today? It's $949.67 because that's the inputs up here. Bond A is a discount bond. It's a discount bond, meaning that it sells for less than the par value. If the annual coupon rate is less than the yield to maturity, then the bond sells for less than the par value. And is a discount bond. So bond B makes annual coupon payments based on a 10% coupon rate. So we can see the difference here is that the coupon rate on the first one is 8%, on the second one is 10%. So it's a higher coupon rate. Everything else is the same. It has a yield to maturity of 9% and a time to maturity of 7 years. What is the value of that bond today? So let's go over here. I'm going to do something here. I'm going to set up a little section where we can just put the inputs in for the bond to get the value today. So let's go ahead and do that. So I'm going to put in my inputs are rate, number of periods, future value, payment, should take care of that for me. So I'm going to put in equal the present value of the price today. So I'm going to put in here PV. I'm just going to highlight my cell that I want there, the rate, the number of periods, the payment, and then the future value. And we can just put a parentheses after this because the type, like I said, will be 0. All right, so I'll go ahead and put the first problem in here, and then we can just change our variables to get our new answer. So my coupon payments are based on an 8% coupon rate. So again, that's $80. My future value is 1,000. My number of periods is 7 years. And my rate is 9%, 0.09. Okay, so I get that 949.67. So now all I want to do is change that payment from $80 to $100 because my coupon rate went from 8% to 10%. And remember, it's 10% times 1,000 to get our $100 payment. And so we see here that our new payment is our new present value is $1,050.33. So the value of the bond today is $1,050.33. Bond B is a premium bond because it sells for more than the par value. If the annual coupon rate is greater than the yield to maturity, then the bond sells for more than the par value and is a premium bond. I want to show you one more type of bond. It's not on here, but it's something important for you to know. So I'm going to go ahead and go back out here to my little setup that I've made with all my variables. Now I want to show you what happens if the coupon rate is equal to your yield to maturity, your rate up here. So if the coupon rate were 9%, we would have an annual coupon payment of $90 instead of $100. So I'm going to go and put 90 in here, and the present value of that bond is then $1,000, and this is referred to as a par value bond. Okay, so the present value, the price of the bond today, is equal to the par value that I'll receive at maturity. I'm just going to type this in here. So when the coupon rate is equal to the yield to maturity, the bond sells at its par value or the face value and is referred to as a par value bond. So that is the effect of different interest rates, the yield to maturities relative to the coupon rates, and how it affects the price of the bond. Now, there isn't a reason other than maybe for tax issues or maybe when you want to receive the income for the bond to prefer a par value over, to prefer a premium bond over a discount bond or vice versa. With the premium bond here, you're getting a higher coupon rate, so you're getting more money in your coupons, but you're going to pay more for that today. Okay, you're going to pay, in this case, about $100 more to receive $20 a year more in coupons. In this case, then you receive a lower coupon, but you're also paying less for the bond. So there's not a, it sounds premium, it sounds good. There's not a, there's not really a preference there, because what investors care about is the interest rate. There are possibly some tax consequences of choosing a premium over a discount bond. That's not where we're not going to go into that topic right now. So the effect of time on bond values. Bond A makes annual coupon payments based on an 8% coupon rate, has a yield to maturity of 9% and a time to maturity of 4 years. What is the value of that bond today? So let's go back to our spreadsheet here. So mind you, bond A is the same bond A up here, except for, in this case, we have 7 years to maturity, and down here we have 4 years to maturity. So 3 years of time has passed for this bond. So we'll see what happens to the price. So before, I'll go ahead and put in the original amounts here. For this bond that we had a payment of $80 once per year, 7 years left, and then the yield to maturity was 9%. The future value was $1,000. So remember, this is the price with 7 years left. And so what's the price now with 3 years having been passed? And so we're going to go 3 years in the future, and there's only four years left to maturity. We can see the price goes up. The price increases to $967.60. Okay. I've got a graphic in the notes that shows that at maturity, that bond is worth $1,000. Okay. Doesn't matter what the interest rate was on that maturity date. The bond is worth $1,000 because that's what you're going to receive as the investor. They're going to give you $1,000. So what happens with a discount bond is, as we get closer and closer to the time to maturity, the value of that bond, or the price of that bond, increases to $1,000. So our answer to that question is $967.60. What is the value of that bond today? $967.60. For a discount bond, as the maturity date approaches, the value of the bond increases to the par value. So bond B, same bond B as above, no differences there, except for, again, going from 7 years left to maturity to 4 years left to maturity. So let's go ahead and do that in our little spreadsheet here. So everything was the same except for we had a payment. So 7 years, we had a payment of $100 for bond B, and our original value was $1,050.33. So I'll put that in here. And then I'm going to change this, and again, 3 years pass. We have 4 years left to maturity, so we're getting closer and closer to that maturity date. And our price of our bond drops to $132.40. So this is the price with 4 years left, or 4 years remaining. So for a premium bond, as the maturity date approaches, the value of the bond decreases to the par value. So I've got a little graphic here that, down below. So right now we don't care about the yield to maturity. We're going to do that next. But as you can see here, with 20 years left to maturity for a bond, bond with a 9% yield to maturity, the value, this is bond A, the value of the bond increases, okay, over time to that $1,000. So the next item we're going to talk about is the effect of changes in the yield to maturity on the value of the bond. Returning to the original scenario but with a different yield to maturity, bond A makes annual coupon payments based on an 8% coupon rate, has a yield to maturity of 11%, and a time to maturity of 7 years. What is the value of the bond today? So what has changed here is we've gone from a 9% yield to maturity to an 11% yield to maturity. So let's go back to the spreadsheet here. So again, I'm looking at bond A. So my rate was originally 9%. My number of periods was originally 7%, and my coupon was 8%. And my original price was $949.67. So the yield to maturity is the market return for the bond, and it's constantly changing. Just people buying and selling bonds for different prices is going to change that yield to maturity. Now, when you buy a bond, as long as it doesn't go into default, you are going to receive the yield to maturity if you hold that bond until the maturity date. So it doesn't change for you unless you trade the bond, but constantly in the marketplace, the yield to maturity is changing. So we're saying here, we start at $949.67. That's at a 9% yield to maturity. So we change that yield to maturity to 11%, and the value goes down. The value goes down to 8.63, and this is with an 11% yield to maturity. So one important thing you need to take out of this class is the relationship between prices and interest rates, or the price of an investment and interest rates. And it is an inverse relationship. Holding all else equal, if the discount rate, and that's what this is a discount rate for an investment, increases, then the present value, or the price today, value decreases. Okay. So in this case, if the yield to maturity increases, the value of the bond today, or the price of the bond today, decreases. So I'll go back out here to the notes. If the time to maturity, what is the value of the bond today? If the yield to maturity increases, it's 858.63. If the time to maturity is 4 years, what is the value of the bond today if the yield to maturity increases to 11%? Okay, so let's go ahead and change our time to maturity. So we're going to take this down 3 years in the future, and we get 906.93. So I'm going to put together a little matrix in our Excel spreadsheet to show you what's happening with the change in time and the change in the yield to maturity for this bond. So we're going to put up here 4 years to maturity, or actually let me make this a little bit nicer, time to maturity. Okay, we're going to have 4 years, we're going to have 7 years, and yield to maturity on this axis, 9% and 11%. So this is our yield to maturity over here, our time to maturity up here. And so what's the value with 4 years left to maturity and a 9% yield to maturity, given the par value and the payment of $80 per year? Because those, by the way, those are things that don't change during the life of the bond for most bonds. So we have 967.60. So that's 4 years with a 9% yield to maturity, 7 years remaining. We have 949.67. With 11% yield to maturity. Oops. That's going to be really weird because it's saying 1100%. We don't want that. And 7 years remaining. So this box out here, it's going to be 858.63. And then finally, we're going to change this to 4 years. Get our last number, 906.93. So what's the difference? So for, a change in the time to maturity, the difference here is 1793. Actually, let me change that a little bit. There we go. So when there's 7 years to maturity, the value of that bond is 949.67. When we go, oh, darn it. So when we go from 7 years to maturity to 4 years to maturity, for a discount bond, the value is going to increase because, again, as we get closer to the maturity date, the value of that bond is going to increase to $1,000. So what's the difference here? It's 1793. If we have 9% yield to maturity, the difference here is 48.30. So at a higher yield to maturity, the change in the price is more as we go through time. Now, if the yield to maturity changes, and this happens quite frequently, usually a 2% yield to maturity change does not happen that quickly. But if we had 4 years left to maturity and the yield to maturity on this bond went from 9% to 11%, okay, so I'm going to subtract the value at 9%, or excuse me, at 11% from 9% because it would be an increase here. The value of that bond would fall by $60.67. Again, if the yield to maturity went from 9% to 11%, the value of the bond would drop by that amount. And in this case, it would drop by, with 7 years left to maturity, $91.40. What I want you to take away from this is, especially these bottom two numbers, the longer the time to maturity, the greater the change in price from a change in the yield to maturity. Okay. I'm going to go ahead and put that out on the document here. So the longer the time to maturity, the greater the impact a change in the yield to maturity will have on the value of the bond. This is known as interest rate risk. Okay. This is known as interest rate risk. Bond B makes annual coupon payments based on a 10% coupon rate, has a yield to maturity of 11% and a time to maturity of 7 years. What is the value of the bond today? So this is bond B, and all we've done here is we've taken that original scenario when the yield to maturity was 9%. And I'll put YTM here. Was 9%. The value of the bond today was $1,050.33. The change in the yield to maturity to 11% results in a new value or a new price of, so let's go out here and we'll calculate that as well. So my rate is 11%. My number of periods is 7. My payment is 100 because that was the payment for bond B. We see it's $952.88. Okay, so we had the same situation. The value of that bond decreased. What's notable here, though, the change in the yield to maturity resulted in the premium bond becoming a discount bond because the yield to maturity increased above the coupon rate. So before, our coupon rate was 9% and our yield to maturity was, our coupon rate was 10% and our yield to maturity was 9%. So the yield to maturity was less than the coupon rate. The change to 11% then made it so that the yield to maturity is now greater than the coupon rate. And so it changed our bond from a premium bond to a discount bond. And here's the graph I was showing you before. This is just for bond A. This is a 9% yield to maturity and the change in value over the change in time. You can see it's not as great. There is a change in value over, with a change in time, because that's going to happen. But the change in value over the change in time is more significant with an 11% yield to maturity. So now we're going to get into annual versus semi-annual bonds. Bond A makes annual coupon payments based on an 8% coupon rate, has a yield to maturity of 11% and a time to maturity of 7 years. What is the value of the bond today? A little hint, we've already worked this one a couple times. So it makes annual coupon payments. So we know up here our rate, let me go back out here, and our yield to maturity is 11%. Our number of payments is 7. Our payment is $80. So it's $858.63. Bond C makes semi-annual coupon payments based on an annual 8% coupon rate, has a yield to maturity of 11% and a time to maturity of 7 years. So the only difference here, Bond A in this case makes annual coupon payments. Bond C makes semi-annual coupon payments. So let's go out here. So what we need to change the rate. We're going to divide this rate by 2 because now we want the periodic rate. Okay, so this is the rate for every 6 months. Our number of periods is going to double. So it's going to be 14. And our payment's going to fall in half. So those are the adjustments we would make. So 1/2 the annual rate. Double the number of periods, so NPER stands for number of periods. And this is half the annual coupon payment, because we're going to receive it twice per year. So those are the adjustments we would make for semi-annual payments. The future value does not change at all because we're only going to get that once and it's a lump sum. So we see here it's $856.16. Holding all else equal, a discount bond with a semi-annual coupon will be worth less than one with an annual coupon. Holding all else equal, and I don't have an example here for this, but I'll just tell you what the answer is. A premium bond with a semi-annual coupon will be worth more, but only slightly, than one with an annual coupon. The last problem we're going to, type of problem we're going to work through here is finding the yield to maturity for the bond. So if we have all the other information and we want to find out the rate of return on this bond, we'll go ahead and work an example of this. So example 1, what is the yield to maturity on a bond that has a $90 annual coupon payment, a price of $9.87, so that's the value today, a par value of $1,000 and 8 years to maturity. So before we calculate anything, we can answer a couple of questions. Is this bond a discount bond or a premium bond? It's a discount bond because it's the price is less than the par value. Will the yield to maturity be more or less than the coupon rate? The yield to maturity will be more than the coupon rate. Because that is the case with a discount bond. If this were a premium bond, the yield to maturity would be less than the coupon rate. So let's go ahead and calculate this out. Go back to Excel, and I will make it so I can see my problem so I don't have to switch back and forth. So now we're not solving for the present value anymore, so we can't really use this. So I'll set up a new one, a little section over here. I'm looking for the rate. So I'm going to put an equals rate. My number of periods, this is an annual bond. So my number of periods is 8. My payment is $90, that's my annual coupon. My present value is negative $987. And if you don't put a negative in here, it's just going to give you an error term. My future value is 1,000, and then my type is 0 in this case. I don't have to put anything in here. My guess, so if there is the possibility that there is more than one interest rate in this case, and there's not, there's only one interest rate, I could put a guess in there, and then Excel will choose the one that is closest. You know, if there's multiple rates available, it would choose the one that is closest to the guess rate that I put in. But I'm not going to do all that. I'm just going to put it in like this, and I get a rate of 9.24%. So that is the yield to maturity on this bond. So the yield to maturity is 9.24%. It is greater than my 9% coupon rate. Example 2, what is the yield to maturity of a bond that has a $50 semi-annual coupon payment, a price of $1,087, a par value of $1,000, and 7 years to maturity? So this is one, we're going to do it in Excel, but this is actually a nice one. If you have a calculator that does time value of money, this is a little nicer because it will give you the annual rate. In Excel, we have to adjust the rate we get to make it an annual rate. So in this case, I'm going to put in, again, this is our second example. This is example 1. This is example 2. So I'm going to put in here equals rate. My number of periods, remember this is a semi-annual coupon. It has 7 years to maturity, but we're going to make this 14 periods because that's the number of payments I'm going to receive. My payment is equal to $50, so it's a 10% coupon rate, but we divide it by 2, the payment by 2, to get the $50 semi-annual coupon. My present value is equal to negative 1087. And my future value is 1,000. So I adjusted my number of periods to 14 from 7, and my coupon payment was already adjusted, but if it would have said a coupon rate of 10%, we would have gotten an annual coupon of $100, and we would divide that by 2 to get the $50 semi-annual payment. Okay, so what we have to do here, this is a semi-annual rate. We need to multiply it by 2 to get our annual yield to maturity. So it's so is this bond a discount or a premium bond? This is a premium bond. The yield to maturity will be less than the coupon rate. And our yield to maturity was less than the coupon rate at 8.33%. And that is it for this set of notes. Please do let me know if you have any questions. Again, I'm happy to provide more examples for you, or meet with you on Zoom to go in any of the calculations that didn't make sense or you're getting a different answer for. Okay.